everybody. Welcome. My name is Jeff DeCorpo, and I'd like to welcome you to this Chip Foundry webinar titled NVM Innovation Contest. This is basically an introduction to an NVM contest that's being sponsored by BM Labs. We have from BM Labs, we have Samarth John, who has joined us, along with my colleague Marwan Abbas, who is going to be available, myself, and he will be available also for questions that you might have during the webinar. A couple of key points before I turn things over to Samarth. One is we are going to be providing recording and slides for everybody who registered to the webinar, so those will be made available. Secondly, if you have any questions, we ask you to please use the Q&A facility in Zoom. So there's a button at the bottom of your toolbar next to the, I don't know if it's near raise hand or it's kind of in the middle of the toolbar, but it basically is titled Q&A, and you can please ask you to please post your questions there. We will be answering those either live or asynchronously as the webinar is proceeding. Okay, I think with that, let me go ahead and turn everything over to Samarth. Samarth?
Yeah.
Your camera is currently off right now. Just
let me check. 1 second.
There you go.
Yeah.
Great.
Hi everyone. I am Samarth Jain, CEO of BM Labs, and thanks Jeff and Marwan for the introduction. Today I am excited to talk about our NVM Power Up Hackathon. It's a global contest designed to showcase the potential of non-volatile memory and in-memory compute. At BM Labs, we develop neuromorphic compute IPs, and through this event, we are giving participants the chance to integrate our NVM IP into real SoC designs and tape out using upcoming Chip Foundry shuttles. This is your opportunity to explore innovative applications in automotive, medical, space domains. Push the boundaries of energy efficient compute and bring your ideas from concept to silicon. So in the next 20 to 30 minutes, we will be covering the NVM contest contents and timeline, how to submit your proposal, our selection criteria, and the final design handoff, which is developed on OpenLane 2 and LibreLane. As Jeff mentioned, all the recordings will be provided and we can ask questions in the Q&A session. So our IP is a analog in-memory compute macro, which is basically a 32 cross 32 crossbar array consisting of ReRAMs and is available on Chip Foundry. It works as a NVM, and the future versions of this IP can also do compute. So for neuromorphic X1, which stands for crossbar X1, is a NVM IP only. So it's a drop-in friendly IP which is compatible with Caravelle SoC using the OpenLane flow, and it's ideal for low latency edge task. Our X1 is a 32 cross 32 ReRAM compute in memory block, comes with an on-chip NVM. It has decoders and sense ADCs as well, and it communicates with Caravelle using Wishbone bus, which is ready to drop in and get your low power from in-place compute using this IP. So what is this NVM Innovation Contest about? The NVM contest, which we also call it as NVM Power Up Hackathon, is a joint contest organized by Chip Foundry and BM Labs, which challenges the participant to build IPs using open source flow, manufacturable SoC designs, showcasing non-volatile memory or in-memory compute on Skywater 130 nanometers. You can join solo or as a team as well. We provide the flow, examples, and mentorship for you to go from idea to silicon. There are two important dates for this event. which is first is a proposal date, which is 17th October, followed by the final design submission on November 3rd. So let's talk about what we have to do on October 17th, which is proposal due date. So the proposal due date is on 17th, which consists of ideation and providing a rough sketch architecture and confirming whether your design is manufacturable on Skywater 130. So you would be required to submit a title abstract specifying the goals of your design and a system level block diagram showing NVM integration with your own design. It should also highlight the feasibility of it being implemented on the Skywater 130. Basically, it needs to be manufacturable, right? So, and you also need to provide a brief background about your team, which will be taking part in the tape out. Close to the milestone, which is November 3rd, and after that, on November 8th, will be the announcement for the winners, which will be selected for this tape out. So how do you get started, right? So how to submit your project proposal? So it's quite easy. If you go to the challenge page, which is available on Chip Foundry, shown on the bottom, you can find a form which specifies to provide a GitHub repo link. So you would have to clone the Caravel user project template, which I will be showing a demo after this slide. So you just have to clone the repo. You have to add a README file outlining your project concept and design proposal first by the proposal deadline. So after that, once your proposal has been accepted, you can upload the GDS files, the verification files, and other files as specified on the Caravel user template, and you can submit by November 3rd. So let's look at the demo of how we can get started with this contest. So this is the Chip Foundry page for the event, for the hackathon, and you can scroll down, you can read deadlines, dates, and basically you just need to click the last link, which is the user project example with our IP. Yeah, after you click it, it will direct you to an example project with the IP and some commands how you can run it using OpenLane 2. So we will be showing you today how to once you have your project ready with all the files like GDS and design, so how do you submit the design for that? So once you have cloned the repo, you have installed the IP as shown in the previous page. Yeah, so over here you will get a folder like this with the IP inside the IP folder, which you can see over here, which is neuromorphic X1. There will be some behavior models which you can use for your behavior level simulation to get started. You can use CocoaDB to do that. And then once you have done your behavior level simulations, you have defined your user project example. Yeah, and inside the Verilog folder as well, we can have a look. So there are user project example, which are the standard file you will find in the example page. So once you have that all ready, you can just open the terminal and use OpenLane 2 to do all the flow for you from PNR, place and route, and verification, things like that. So only after this command you will have your full IP, all design ready with this. So it's going to do the routing for you. It's also going to check the constraints, SDZ files and things like that. So let me try to speed it up because it's going to take some time to do routing. So it's starting to do routing right now. So it's taking the macro, which I'll be showing in the end. It's taking the macro and it's placing in the user project area, and it's doing the routing as per the macro requirements. So let's just speed forward the routing part. Yeah, so it'll also do LVS and stuffs like that for you. So it's a complete open, open lane compatible. So I'll just try to speed it up. Oops. Yeah. So over here we can see that it has passed LVS, DRC, antenna checks. So this is a local check you can do at your end. Once this is clean, you can go to open lane user project wrapper runs, and you can just view your final GDS which you need to submit for this event. So let's try to open the GDS generated and see how does the macro look. So this is the GDS file which was just created by that flow. So we'll just try to open key layout and import that file in it. Yeah, so we'll try to find that file and just import it. So it should be the latest run. Okay, so these are all the files generated by each and every step in the open lane flow. So we'll just go to the final generated file, and in that there should be a GDS. Yes, so we can just import this final GDS file. So after this, the only step left is you have to submit to the chip foundry platform and just have one more check of the manufacturability of this design. So you can see over here there's a macro connected to bottom pink wires, which are the LA pins, the digital pins, and it has also routed the analog pins. So we can just zoom and trace a few wires over here. For example, this is a wishbone pin which is connected from the wishbone, which is the caravel interface, and that will be interacting with the slave wishbone inside the neuromorphic X1 IP. So we can try to follow this wire a bit. Just let's try to see the one single wire and see how it's connecting. Yeah, so we can try to maybe speed it up a bit as well. Yeah, so all these wires go and connect to the IP wishbone slave interface, which is the wishbone data over here. Yeah, so that was how you can submit your design. It's quite easy. Let's move on to the next section, which is the selection criteria, right? So for selection, there are a few key points which we are taking consideration of. First is the relevance. That means that the IP should be used, the NVM IP, the X1, along with your design, whatever design you have. It should be using the NVM IP in a meaningful manner, which is like not something with a normal EEPROM could have done, right? So it has to be a little bit different from a normal memory access. It should be feasible to be manufactured on Sky 130 and should be compatible with the Caravelle constraints. The GDS should be generated like how I just demonstrated. It should be open source compatible. That means you need to make a GitHub repo with all the scripts in it. It should be reproducible, right? And other details about that you can find on the event page. The system should be very clearly defined. It should be using clear bus interfaces. There should be a proper clock usage, and there should be a verifiable test bench available, which we are going to use CocoaTB to verify, and it should all be uploaded in your GitHub repo. It should be impactful. That is, the edge AI which you're trying to do should bring some value to medical, automotive, or space kind of application segments. So I would like to give some specific examples now so that people can get started with the ideation, right? And maybe think about building teams. So the first example, which is the analog sensor interface. So what I'm trying to show over here is that you can use a sensor. It can be a CMOS compatible sensor. It can be, I mean, camera or some sort of light sensor, audio sensor, right? It can be any kind of sensor, and then you can make an analog front end, which is the AFE mentioned over here, and then that analog front end can directly feed the data to the crossbar array. And that's possible because in the crossbar macro, if you look deeply, the program set reset voltages are given access to the user. So you can play with those voltage and try to do some thresholding to manipulate the programmability. Or if you directly want to send the data from analog front end through the microcontroller, which is the RISC-V, you can just interface it with the wishbone and then send it through the IP's wishbone interface. So with this example, you could use it for maybe example keyboard spotting or some sort of detection. It can be used for tiny vision task, but the focus with this example could be that you can use it for deterministic latency applications where the latency has to be fixed, right? Because your analog front end helps you directly store your data into the crossbar, so you can have a deterministic latency, and then you can also have a measurable accuracy with this kind of design. So it's not using it as a normal NVM, but it is using an analog front end with the sensor and then sending the data to the NVM. So with this you can do signal processing, pattern detection, and things like that. There are other aspects of ReRAM as well. For example, ReRAM can be used for radiation hardened kind of applications. There are ample amount of proofs, ample amount of tests done by NASA and other publications. And it's just because ReRAM doesn't work like flash, which is charge based. ReRAM actually has filaments, which are solid filaments, and there are ample amount of tests done using these ReRAMs and proving that they can be used for applications where radiation hardened might be required of some sort. So the quick examples for those kind of applications can be medical or applications where you need to have long hibernation missions, right? Or it can be used for automotive applications where you need some sort of better reliability. So over here I'm just giving example of how you can use it for maybe some sort of capsule endoscopy, or you can use it for some sort of Mars rover kind of things. The last example is also related to medical. So because I mentioned it can be radiation hardened, you can use in uh, you can use it, for example, logging the radiation in medical devices or places where the data is very sensitive, like calibration data for these kind of devices. So you can use it in those applications. Yeah, so finally, the X1 uh, is available for prototyping and licensing. It's a 32 cross 32 NVM macro, which can be used, as I showed, for sensors, radiation hardened applications, automotive. Maybe it can be a part of ADAS and things like that. So feel free to contact us if you would like to use the IP separately apart from hackathon. But if you want to participate in hackathon, you're more than welcome, and your tape out will be sponsored by us. Jeff, I think that's all. I think we can take Q&A after
Yeah,
this.
super. Let me go ahead and put my camera back on. I think Smart, your camera has stopped as well. But that was good. You want to check, but okay. So to just going through questions, we did have a number of questions posted, and I think one of them I just want to clarify. There was a question about whether someone needs to use Caravelle, the Caravelle template specifically. And just to clarify that, what's required is that it has to be manufacturable through Chip Foundry, MPW shuttle. So you need to use one of the templates that are supported by the Chip Foundry MPW shuttle program. So that could be Caravelle, it could also be OpenFrame. Either those would be acceptable. I guess technically you could potentially do something with Caravan, although Caravan's really only meant for prototyping. Use cases, but ideally this would be a reference design that can be used for a real application. So you'd ideally use one of the other two. I don't know if you have any other comments on that, Samarth, or
Yeah, I think that's right. It was just an example. It can use any of the frames provided by Chip Foundry, and it should just include the NVM as we mentioned.
yeah. As part of that, it can also use any flow. I mean, obviously, open lane or Libra lane is what Smart showed, and that's kind of what the reference that we provide. But if you have another open source flow, that's acceptable. So we'll accept GDS. We can manufacture GDS as long. I mean, the main thing is the project is publishable, open source, and can be reproduced by somebody. All right. Question about where do you register? So we posted the link. I think. Do you have the link in your slides as well, Samar?
Okay, yeah, sure. The link is over here. It's on
Okay.
the Chip Foundry
Yeah.
challenges under BM Labs.
Okay. Yeah. So if you go to the chat to the landing page for the challenge, you'll find a link or a form at the bottom to submit your proposal. Again, those are due on the 17th. So we're looking for, and that's just really for the initial proposal that needs to get submitted at that stage.
Yeah, I think a lot of people approached me that they got confused whether 17th is the deadline. It's not the
Yeah.
deadline, it's just the proposal deadline in which you just need to make a GitHub with a proper README file, and that's all. And after that, once your project is accepted, then you can work on the final, which is I think November 3rd. Yeah, November 3rd is the deadline for GDS submission.
Yep. So new one. So as I'm new to Caravel, I just want to know if there is any example project where they have used this IP for sure. Oh yeah. So there we can point to a number of different example projects. Actually, the template itself. So if you'll go to github.com/chipfoundry, the Chip Foundry organization, you'll find a couple of templates for starting a project. One of them is called Careable User Project. That project itself contains an example in there that you can repeat. Also, there's the example that Samarth just showed is also available, and so that if you want to see an example with the X1 IP implemented already in it in Caravelle, you can clone that and try it and repeat kind of what you saw Samarth walk through. There's plenty of other examples. If you look at eFabless and go back and look at eFabless and Caravelle, you'll find many people and many projects that have been published using Caravelle.
Yeah, I think that's a good starting point. Like in the old eFabless repo as well, there were a lot of open source design which people can try combine with this IP. Like there are a lot of regulators, there are some ADCs, DAGs, there are a lot of available open source IPs with GDS, everything available.
Okay, I'm just looking through the rest of the questions we already answered. I think we covered most of it. Again, for people who you were asking about this webinar is being recorded, and a recording link will be sent out after later today or early tomorrow morning, including including the slides. So everyone will receive that. Other than that, I don't see additional questions right now at this time. There are definitely, just a reminder to, feel free to reach out to us. I think there's info, there's a email, there might be an email link in there, but probably one of the best ways to reach us is the Discord link that Smart showed. So there's a specific dedicated channel for the contest, and you can post questions there as you if there's something that we didn't answer, or you need further clarification on. And there's also our email there, info@chipfoundry.io. That will also is a way to reach us. There's also a FOSSI chat there as well. Which we monitor. Okay, well, thank you, Samarth. Really appreciate the presentation, and really looking forward to everyone. I also appreciate everyone joining in their time today. I look forward to seeing your submissions, and please reach out to us if you have any further questions. Thank you for attending.
Thank you, Jeff.
Bye.